This object orbiting the star right here is a planet called Osiris. This is a type of object referred to as a hot Jupiter. A Jupiter-like planet that is very close to the star, that starts emitting a lot of materials because it's basically being scorched by the sun, by the star. Now today we're going to talk about one such star because it's very unusual for being the darkest object in the universe. Or at least in our galaxy that we found so far. Let me show you what it looks like by going into the search box right here, and we're just going to write down its name, which is TrES-2. TrES-2b specifically, also known as Kepler-1 planet. Now it doesn't exactly look very dark in Space Engine, but it is a very unusually dark planet. And this is what it looks like in Space Engine. So you can kind of see the emissions coming from behind the planet caused by the star right here. Now, this particular planet, we're going to investigate more in Universe Sandbox 2. But what you need to know about this is that it is darker than charcoal and darker than the blackest color you've seen in your life, even though it doesn't actually look that dark here. Welcome to What the Math, and I hope you enjoy this video. Now, there's only one way I found that where I could actually try to simulate how dark this planet really is, and this is, of course, in Space Engine again. If I were to basically look at TrES-2b and use these settings right here, I can kind of give you an idea of how this planet looks like and how dark it is. So first of all, we're going to basically reduce the exposure levels here until it is barely visible. And now, because it's actually kind of, it's unfair to other stars, we're going to increase the magnitude of other stars and make them visible in the background. Now, this is kind of what this planet looks like in reality. It is that dark. It is basically a dark blob in the middle of space. And if we were to actually try to, land here or try to approach this planet from the outside using whatever space devices we have in the future, spacecraft of course, we might actually crash on it because we might not even see it. We'll just obviously not see stars behind it, so that's the only way we'll know there is something there. But because this is a very massive object and because this object is essentially very dark, it's kind of dangerous. And so this essentially is what this object looks like in real life, and this is how dark and how ominous and scary it really is. Now, unfortunately, because I changed the settings here, I can't really show you the star because the star also changed its appearance, but that's because we just played around with the exposure levels. This is what TrES-2b is like if you were to essentially approach it and if you were to be in its orbit. It's almost like a black hole, except for, of course, that it's not. And let's actually investigate this planet using Universe Sandbox 2 because it's also available in this game as well. If you go under Add right here and you type TrES-2 or TrES-2, you'll see that there's both the planet and the binary star of which it's part of. Now, we're going to just place it here for now, just so I can show you what it looks like in this game. We're going to zoom into this, and so here's what it looks like in Universe Sandbox 2, but once again, this is not a real representation. So what we know about this really awesome planet is that, like I said, it is the darkest object in the galaxy. What this means is that its albedo is, even though it's 0.3 in this game right now, it's actually lower than 0.01, lower than 1%. What this means is that it essentially reflects less than 1% of all of the light that it receives. Or in other words, it actually absorbs most of the light, creating this really interesting dark shape in the middle. So if we actually take a look at Vesta here, which for some reason also has very low albedo, even though in reality it doesn't, it kind of possibly looks something like this without the white spots. So if you were to look at this gas giant in a distance, it may actually resemble this, which is kind of unusual. Now, I don't think Vesta will look like this if I turn this into a gas giant. Yeah, it looks something completely different. But nevertheless, it's essentially a very dark, very black, and very scary looking gas giant. And in comparison to our own gas giant, so remember this value right here, this is 1% reflection. If we take a look at Jupiter, its albedo is 34% or 0.34, which is relatively high because of the clouds that it has. It actually reflects a very, very large amount of light. And if we actually compare this value to other objects in our solar system, you'll be quite surprised. So, for example, one of the highest albedos in our solar system is Venus, and here it should be actually 0.90. Venus essentially reflects something like 90% of all of the electromagnetic spectrum. So all of the light that falls here essentially gets reflected back into the outer space. If its albedo was even lower than that, if I were to actually decrease its albedo to what you just saw, 0.01, its surface temperature would be even larger. And I think its temperature actually stabilizes around 1,000 degrees Celsius. So if it had albedo of that gas giant, this is how hot Venus would actually be. It's pretty impressive. There's another object that even has a higher albedo, and this object is right under here. It's one of the moons of Saturn, and this object is called Enceladus. This particular moon has albedo of close to 1. It's actually 0.099. Essentially, it reflects 99% of all of the light it receives, and this is mostly because of the material that it has on its surface. Now, it doesn't actually look like this. It looks a lot more beautiful than this. But it is the most reflective object in our solar system. But when it comes to least reflective objects, that would actually surprisingly be Mercury. So Mercury absorbs quite a lot of its solar radiation, solar light, and its albedo here is at 0.12. The actual value is closer to 0.07. So it's about 7% of light that is reflected, and the rest is absorbed by Mercury's surface, which is of course one of the reasons why it's relatively hot here. It's a pretty warm planet. But even this is nothing compared to TrES-2, TrES-2b specifically. If we go back to TrES-2b, and we're actually going to just create the system from scratch here. And so here is TrES-2b. And even though it's a very, very hot Jupiter, as it's called, it's a gas giant that's very, very close to the star and is ridiculously hot, its albedo is only 0.01. So even though it is very, very hot, it doesn't actually reflect that much stuff and is essentially as dark as charcoal. So this would technically be completely black right now. But what's interesting about this planet is that it's in no way different from Jupiter. As a matter of fact, it's very, very similar to Jupiter in composition. It's a little bit more massive. It's about 25% more massive than Jupiter. And really the only difference that it seemed to have is that this is the darkest exoplanet in existence, so that has been found so far. So maybe there are some darker ones that we haven't seen yet because they're so dark, but this is definitely the darkest object we've actually detected in the galaxy. But what's even more mysterious is that we don't actually know why it is the darkest object. We have no idea or no scientific theories about why it's actually so black. And one of the possible explanations is that it might be actually, it might not have any reflective clouds on the surface. So Jupiter, if you were to take a look at Jupiter again, I'm going to place it a little bit farther away here, somewhere here. Jupiter has these reflective clouds on the surface that essentially are responsible for, reflecting a lot of the stuff back into the solar system. However, TrES-2b, because it's so close to the star, may have lost these clouds due to essentially star just, bombarding it with various solar radiation. And so a lot of these clouds may have just dissipated and disappeared. So that's one explanation, but I'm not sure if it would make it that dark though. It might be a little bit less bright, but it wouldn't be completely dark and completely black. But there's also another explanation that maybe it's just because of the chemical composition of the planet. That would be actually a very interesting and very unusual explanation, but it's possible that inside of its atmosphere, it has these light-absorbing chemicals. For example, vaporized sodium. If there's sodium in vapor form, it might actually absorb a lot of the energy. Also potassium as well, and even more exotic things like titanium oxide, which actually is responsible for making various things on our planet really dark. If there's titanium oxide in this atmosphere, it would absorb light and make this a very, very black gas giant, but all of these would have to be in gas format. And because most of these hot Jupiters, these planets that are very massive, that are very close to the star, are usually relatively bright, it's very unusual for this one specifically to be so dark. And what I actually wanted to kind of show you in this particular video is that these gas giants, these so-called hot Jupiters, are actually not as rare as we think. As a matter of fact, many solar systems seem to have them. And it's very likely that we'll find more of these gas giants that will have either very, very bright atmospheres or very, very dark atmospheres. And once we actually start exploring stars and start going to those stars and exploring those other solar systems, we'll very likely find that almost all of these solar systems have these really unusual, very massive objects close to the star called hot Jupiters. It's very unusual that our solar system doesn't have one, and we'll talk more about this in one of the future videos. Now, in this video, I just wanted to kind of show you an idea that there are some really dark objects out there that are not black holes, and one of such objects is this planet that we found that is known as TrES-2b. You can find this object both in Universe Sandbox 2 and in Space Engine, and you can take a look at it there as well. Now, I hope you enjoyed this little video, and I hope you learned something from it, and now you know more about hot objects, dark objects, and gas giants close to stars, and specifically now you know about TrES-2b, the darkest object that we've found so far. Thank you so much for watching, guys. I appreciate all of your support, and thank you so much for subscribing and for liking and sharing this video. I'll see you in the next video where we'll talk more about other things, about space, math, science, and all the other fun stuff that you and I like so much. I'll see you guys later. Game you later. Bye-bye.